Hello everyone, in this video I'm going to solve these 10 derivatives and we are going to have a review of all the differentiation rules. So let me start by the first rule. If we have a function f of x, df dx would be the notation that we use for taking derivative of f with respect to x, or sometimes we use f prime of x. So when we have a number times x, derivative of that would be just the number. And if we just have any number and we take derivative of that, we get 0. Another rule would be x to a number, derivative of that would be n x to the power of n minus 1. And if we have any function u to the power of n, so u is a function, then derivative of that would be n minus 1, exactly like the power rule that we explained in here. But since u is the function, we need to multiply this by derivative of u. This is called chain rule. Chain rule. Okay, so let's solve the first example. Derivative of x to the 4 minus 10x cubed plus 4. Derivative of x to the 4 is just 4x cubed. Then derivative of negative 10x cubed. So I need to keep negative 10 just because it's the constant. I need to keep it. And then x to the power of 3, derivative of that would be based on the power rule that we explained in here, would be 3x squared. So together, this part would be 30. And derivative of 4 is just the number, derivative of that is 0. So as you see, if we have some functions that are added together or we have a negative sign between them, so we can just split the derivatives. Let's go to the next one. As you see here, I have a function here to the power of u, to the power of 5. So this thing in here could be like u. So I have u to the power of 5. Derivative of that would be 5. The function, whatever that the function is, which is 1/2 x to the 4 plus x 1/3 to the power of 4. So I just wrote this part of the chain rule. Now I need to multiply it by derivative of the function that is inside, derivative of u. So derivative of the inside function, I have 1/2. So I'm going to keep writing 1/2. And then x to the 4, it would be 4x cubed plus x to the power of 1/3. So 1/3 x to the power of 1/3 minus 1. 1/3 minus 3/3 is negative 2/3. So I can simplify that to negative 2/3. This one doesn't get any power. This is just u prime, okay, in the chain rule. So if I want to go to the next one, what do I have? I have a square root, but since I just want to use these formulas for square root, I can rewrite this as x to the power of 1/2. Okay, and then this one would be what? This is negative 3 x to the power of, so this is square root of x to the power of 5. It would be x to the power of 5/2. You can use this rewriting for any kind of a square root or any kind of weird exponent. Okay, so now in this case I can use power rule again. So x to the power of a number, x to the power of number, derivative would be 1/2 x to the power of 1/2 minus 1. And then I have this part, negative 3 x to the power of 5 over 2. So I need to keep writing negative 3 and then x to the power of a number. So the number comes down, 5 over 2, x to the power of 5 over 2 minus 1. So if I want to simplify that a little bit, so 1/2 minus 1 is negative 1/2. And then negative 3 times 5 over 2 is negative 15 over 2. 15 over 2. And then I have the exponent 5 over 2 minus 1. Minus 1, I can write this minus 2 over 2. So the exponent here would be 3 over 2. Perfect. Now for the next one, I can rewrite 1 over x as x to the power of negative 1. So since x was on the denominator, when I bring it up, the exponent gets negative. Then in here, I have 1 over square root of x. So square root of x would be x to the power of 1/2. I can bring it up, so the exponent gets negative. So this is x to the power of negative 1/2. Perfect. Now I can use power rule again. So derivative of x to the negative 1 would be negative x to the negative 2. Then I have a big minus because of this. Then I get negative 1/2 x to the power of negative 1/2 minus 1 minus 1. Okay, so if I want to simplify that, this would be negative 1 over x squared plus 1/2 x to the power of negative 3 over 2. If I want to bring this down, it would be 1 over x to the power of 3 inside the square root. Very good. Now for the next one, we need 2 more rules. So if I want to give you a rule, e to the power of any function, derivative of that would be e to the u. So you're going to rewrite e to the u, whatever the function u is, you're going to write that, and then times derivative of the function. Okay, now if we have a to the power of u, basically any number. So here the number is e, which is 2.71, but in this case would be any number to the power of u, then derivative would be a to the u, exactly like here, times u prime. Now this time I need to multiply by ln of a. Here I multiplied by ln of e, but ln of e is just 1. That's why we don't write this in the formula in here, but this is the general case. Okay, so now let's go in here. We have e to the power of root 2 times x. So derivative of that would be e to the power of root 2 times x times derivative of the function, which is inside derivative of this part, would be the number, times x, derivative would be just the number. And then plus, I have a number to the power of a function. Derivative would be the number is actually 6 to the power of 1 over x times derivative of 1 over x, derivative of that, times ln of 6. Good. What is derivative of 1 over x? I can rewrite that as x to the power of negative 1. And so derivative of that is just negative 1 x to the power of negative 2. Okay, so instead of this, I can write negative 1 over x squared, which is basically the derivative of 1 over x. Very good. For the next example, I need to review the product rule. which is what? If I have a function u and I multiply it by a function v and I want to find derivative of that, would be derivative of the first one, u, times the second one, plus derivative of the second one times the first one. So basically derivative of u times v plus derivative of v times u, okay? So this is the rule that I'm gonna use in here. I have a product of two functions, okay? Now for that, it would be derivative of the first one, derivative of x cubed would be 3x squared times the second one, e to the 2x, plus derivative of the second one, derivative of e to the 2x, okay? So it would be e to the 2x times derivative of 2x, okay? E to the 2x times derivative of the 2x, which is just 2. Okay, very good. Now let's go to the next one. The next one, I need to review the quotient rule, which is what? If I have a function u divided by a function v and I want to find its derivative, derivative of that would be denominator square, whatever function that you have in the denominator gets a square, and then derivative of top times bottom minus derivative of bottom times top. Okay, very good. Let's go into here. So I have a big fraction. Okay, so denominator gets a square, 8 minus x cubed, whatever that you have on the denominator, it would be square. And if I want to simplify that, it would be the parentheses to the power of 2 times 2, which would be the parentheses to the power of 4. Okay, so I wrote just this part. Now, derivative of the top times bottom. So derivative of this function, it is chain rule. I have a function u to the power of 4. Okay, so let me write this in here. So this is u that gets to the power of 4. As you see, this is chain rule. It is what? It would be 4 u to the power of 3. So whatever that you have as your u to the power of 3 times derivative of u. So derivative of this part would be 2x. Very good. So that is derivative of top times bottom, which is 8 minus x cubed squared minus derivative of bottom times top. So derivative of bottom is what? Again, I have a function u to the power of 2. So I have a u squared. Then I need to use chain rule. 2 gets down, u to the power of 2 minus 1 times derivative of u. So it would be 2, 8 minus x cubed to the power of 2 minus 1, which is just 1, times derivative of u, which is negative 3x squared. Okay, so that was derivative of bottom times the function that I have on top, which is x squared minus 7 to the power of 4. Okay, that was the big fraction. Very good. For the next one, I need to review derivative of natural log, which is what? Natural log of any function, u. Derivative of that would be 1 over u, 1 over whatever function that you have inside, times u prime. Perfect. Now let's go in here. I have ln of a function, okay? So derivative of that would be 1 over the function, which is e to the power of 4x minus 5x squared, okay? Times derivative of this part, So what is derivative of that? Derivative of e to the 4x, okay, as we reviewed in here, it would be e to the 4x times derivative of the function that is inside, which is 4. Now, minus derivative of 5x squared, which would be 10x. As you see, this is 1 times this function, so I can write the function over 10x over e to the 4x minus 5x squared. Or basically, I can write derivative of ln of u as u prime over u. Okay, very good. What else? Now, let's go to this function. Okay, so for this question, I need to review derivative of cosine and sine. Let me make this one a little smaller. Okay, so derivative of sine of any function. It could be x or it could be something else. Derivative of that would be cosine of u, okay, times u prime. I can rewrite this as this one, maybe it's better. Derivative of inside times cosine of u. If we have cosine u derivative of that, it would be derivative of inside times negative sine of the function. As you see, when cosine gets to sine at its derivative, the inside function does not change, but you multiply the whole thing by a derivative of the inside function. So let's look at here. I have e to the power of a function. Derivative of that, as we reviewed, it would be the same thing. I mean, e to the 10 cosine of pi x times derivative of the function. So derivative of 10 cosine of pi x, so 10 is just the number, I need to keep it, and then cosine of a function u. Okay, derivative of that, it would be derivative of the inside function, which is just the number times x, so the number pi, okay, times derivative of cosine is negative, let me put the negative in here, negative 10 pi times sine. When I want to write the angle for the sine, I just write the angle that I have for the original function. Then minus e to the power of ln of x squared. So let me give you a kind of a recall. If we have e to ln of any function, anything, star, it would be star because the function ln and the function e, they are inverse of each other. So e to the ln of x squared is just x squared. In that case, derivative of x squared, just negative 2x. I mean, I have a negative sign, and then this part is just x squared, so it is negative 2x. Okay? If you don't remember that part and you really want to find e to the ln of x squared derivative, okay, let's look at that. I have e to the power of a function. Derivative of that would be e to the power of the function itself times derivative of the function. Derivative of ln of x squared would be what? As we explained in here, would be derivative of the inside function over the function. So derivative of x squared, which is just 2x over the function, x squared. And as you see, this part is just x squared, so together I have x squared times 2x over x squared, so I got 2x again. Okay. Now for the next example, we're gonna just review everything. Okay, let's see. we have okay, we want to find this derivative. We have square root of a function. Let me just rewrite that as, so this is d dx of, let me rewrite this function as 1 minus e to the 2x plus 3x over sine x to the power of 1/2. Okay, as we explained before, any kind of a square root, okay, you're gonna write this as something to the power of 1/2. And then plus x cosine of 4. Now look at this part. This is x to the power of 1/2. I'm gonna bring it up so that the exponent gets negative. Okay. Let me move this part. So allow me to do that. Just a little tap. Okay. So that's the function. I would like to find its derivative. So I have a function to the power of 1/2. So derivative of that would be 1/2 the function 3x over sine x to the power of negative 1/2 times basically 1/2 minus 1, right? So 1/2 gets down, whatever that you have to the power of 1/2 minus 1 times derivative of inside. Derivative of 1 is 0 minus derivative of e to the 2x would be 2 e to the 2x plus I have a quotient rule to use in here, which would be whatever that you have on the denominator square, derivative of top, which is 3 times bottom, minus derivative of bottom, derivative of sine is just cosine, right? Because sine of x would be derivative of x, which is 1 cosine of x. So derivative of sine is cosine times top, 3x cosine x. Very good. So I found derivative of the first parenthesis. Now for the second one, I need to use product rule because I have two functions that gets multiplied to each other like this. So using product rule, it would be derivative of the first one, which is just 1 times the second one. So plus 1 times cosine of 4x to the power of negative 1/2 plus derivative of this part, the big part, times x. So I'm gonna write x, I don't want to forget it, and then derivative of cosine of this point. So cosine of u would be derivative of u times negative sine of u. So I'm gonna write the negative sine of u, which is this function, times derivative of the inside function. Derivative of that would be what? 4 times negative 1/2 times x to the power of negative 1/2 minus 1, which is negative 3/2. And it gets multiplied by the first function, which we already did. Great. So let me make it a little smaller so that you can see all the rules. These are all the rules that we use.